Hey, listen, I didn't get to point this out yesterday because it didn't occur to me until later. So I thought I would share the joy with you that I was able to share with Fifth Hour. Yeah, this is not today's date. This is yesterday's date. And do you know yesterday was 8/27? Do you know this is cosmic numerology stuff? If you're into that kind of thing, how numbers and existence are like related. Woo. Yesterday, we learned about cubes, right? And look, the date yesterday was a cube followed by a cube. What are the odds that, I mean, that's rhetorical. I don't know the answer, but like, what are the odds really that on the day I teach you about cubes, the date is comprised of cubes? Two cubed, three cubed. No one is blown away by that? Are you patronizing me or like, is that legit? Yeah, right? So, all right. Today is not as interesting. Today is the 28th, and we're doing more sums and differences of cubes, but these are going to be higher power cubes. And our discussion that started the lecture yesterday is going to pay dividends here because I won't have to go through the introductory idea of what is a cube and what is not a cube. So we're going to start with this example, x to the sixth minus 125. As this factoring unit gets harder and harder, I cannot stress enough the importance of you being able to look at a factoring problem and identify it. So our job is to look at this problem and be able to say, I know you, you're a difference of cubes. And as per our discussion yesterday, we can feel good about that because I'm sorry for this, it's rhetorical, but I still want to hear you say it. Is that a cube? It is. And if you've forgotten in the last 24 hours, remember anything that has a power that is divisible by three is by definition a cube, right? So big question now is if I give you this difference of cubes, what is A? It is x squared, right? And that whole divisibility by three thing is the key. Like if I can identify A, sometimes it'll be obvious, like finding B is going to be easy, but finding the one with the variable is a simple matter of dividing the exponent by three. So if the term itself is x to the sixth, then A divided down is x to the second. What's B? Correct. And we're going to follow the exact same template. Like that doesn't change. It's a difference of cubes. The template that we use isn't going to, suddenly change. It's just the idea sometimes of finding A and B can be a little bit more of a stretch. And then there's a little bit of extra work, a little extra thinking when we plug them into the shells. So let's get going. What's our short set going to be? Perfect. And it's always going to be A minus B, or in this case, what you said. All right, a little rough spot here. What's going to lead off long set? X squared squared, which I cannot with a clear conscience write. I can, however, write x to the fourth, right? And I appreciate that. That's exactly what you should be thinking, is that it's x squared, but squared. And so the rule, the property of exponents is, and I'm just going to write this in purple here, that if you have something that already has an exponent and you exponentiate it again, we know our properties that we multiply those exponents together. Nice. What's the middle term going to be? Plus. Thank you for saying plus. That means a lot. Plus what? Perfect. It's just AB, right? And then what's my last term going to be? Good. I will caution you sort of like a spoiler alert, foreshadowing. That's not, I don't know what the right word is, but come Monday, do you identify, by the way, this problem's over. I just want to ask you this. Do you see how close that thing I just circled in green is to being factorable? What's it really close? What's it trying to be? It's really close. It's from your past, like last week. Let me ask you this. What if I changed 5 and don't do this in your notes because someday you'll look back and go, what happened? But if this were a 4, what would the thing in the green egg be? It's factorable. What kind of polynomial is it? It has a name. It was on your factoring quiz from whatever it was. Say it again. It's called a difference of two squares. And what's going to start happening to you? This is what I almost threw in today, but I called an audible on myself and said, like, slow down, big guy. What's going to start happening on Monday is we will be in possession now of knowing how to factor cubes, quadratics, lookalikes, and then I'm going to start throwing in factors themselves that are subsequently factorable again. And that's when factoring kind of, I think it's a little bit, that's the first big step in difficulty is when the offspring produces their own offspring, so to speak. So we're going to have multi-layer factoring starting on Monday. But for today, I double checked and none of our problems can go more than the one step. So for now, this is a 5 and this problem is over. Good. Savannah, would you be so kind as to shut that door? There, I don't know what kind of chaos is going on out there. It sounds like they're having a party that we weren't invited to. Boy, you all right there?
Yeah, just take a little break, clear it out.
Okay. So based on knowledge acquired yesterday, what are we going to do first with this guy?
Well, then the
Thank you for saying that. Pull the negative off. Good. Remember, we don't want to proceed with factoring of any flavor when the leading term is a negative. So we're going to take a quick moment and we're going to pull the negative outside and we're going to rewrite the problem. The problem that I actually want you to factor is 343x to the ninth plus 216. So I use colors. I don't know how you take notes, but that red to me, I want that to stand out as the timeout guy. Like he's just hanging out right now while we do our thing. And the same question, as always, what is A? No. Nice answer. So A is 7x to the third. And again, you got the memo. Just divide exponents by 3 when you want to cube root something. Simple pimple. What's B going to be? Nice. So really the crux of the newness for today is that I want you to be able to work with higher powers. And it's really not that much of a jump. So here we go. We're going to build our template. We're going to go short set, long set. And if you're like me and you tend to forget things, then it's okay right now to just before you forget, copy that negative down. And then you don't have to worry about it later. All right, so let's do this. What's our short set going to be? Perfect. And this, I said it yesterday and I'll say it again. This next thing is where 95-ish% of mistakes happen in my experience. What's the first term going to be? Nope. Yes. And that was exactly the mistake that people make because they forget. We get so excited about that newly acquired knowledge about doubling the exponent that we forget about the 7. So when you square something, you square all of it. So 7 squared becomes 49. X to the third becomes x to the double third, which is 6. Okay, so you're learning that when you cube root something, you divide the power by 3, but when you square something, you multiply the power by 2. What's the middle term going to be? Minus. It's negative 42. You're fine. X to the third. And then the back term, plus 36. Okay. Some questions on that one? Okay, these next 2 examples really will not be any more difficult. I just thought doing 2 and stopping would be unfair. So you now understand how to do this. We're just going to knock out 2 more problems. So the next one is 27 x to the 12th minus 64 x to the 9th. Are they both cubes? Yeah, the whole thing reeks of cubes. 27 and 64 are nice, perfect cubes, and the exponents are powers, or not powers, but multiples of 3. So that's what we want to see. Nothing to pull out, so what's A? 3x to the 4th. Remember, at this stage in the game, we're cube rooting, and that implies division by 3. What's b going to be? 4x cubed. You see at this point in time why it's so ungodly, ridiculously important to write down what A and B are. Like not having track of those would be a nightmare. But now that they're written down, you just plug them into the template. So template is short set, long set, and we're off. What's going to lead the way?
3x.
Yep. A minus B, right? And well, so that's just, don't change it. You just like copy it in there, right? Don't do any math in the short set. You just copy and paste in the short set. The long set is the math. All right, let's do this. What's going to lead the way in the long set? No, 9x to the 8th. And there's always at least one person in the room who doesn't get it and isn't asking. So I'm just going to show this like for recording / your notes that this number, this term right here was acquired by doing a squared, which we can see is 3x to the 4th squared, which you can see if you go 3 squared, that's where the 9 came from. And if you do x to the 4 times 2, that's where the x to the 8th came from. Okay. So in case you were hiding and not wanting to ask, that's what it is. And then the rest is going to be pluses. So I'm going to put a plus and a plus. I've already spent my minus. What's going to go in the middle? What is x to the 4th times x to the 3rd? Tell me, what do you see? How many x's do you see? 7. You ever forget your properties of exponents, you can teach them all to yourself on the fly by just writing down the problem. Because it happens all the time where people wonder, like, should I multiply 4 and 3 or should I add them? And the answer is, well, the add them is the right answer. But if you forget, just write it out. And then you're like, oh, there are 7 x's in front of me. It must be x to the 7th. And then what's the back term going to be? Plus what? 16 x to the double 3, which is 6. Got it? One more. Hopefully it's set into the point where you're starting to feel a little bored. If not, let's hope that the 4th one does the trick. So last one. 1 minus 512 x to the 21st. What's A? I think he said what the flip.
Wasn't sure.
Yeah, hence my confused look. I'm gonna go with what's that? Ah, boy. So A is 1, right? And we know how to do this. What's B? 8x to the 7th. Divide the exponent by 3. And now that we have our cast of characters, we do what we have been doing for a while now. Build your template. Remember, the short set is a no math zone. It's copy and paste, right? What's the short set going to say? 1 minus 8x to the 7th. And I will use a color here because I've got my colors and you know I like to use them. Please remember that the short set sign will always mimic the sign of the original expression. And the good news is we've used our minus, which means it's smooth sailing plusville from here. And what's going to lead off the way in long set? 1, because 1 squared is 1. Plus 1 times 8x to the 7th is 8x to the 7th plus what? 64x to the 14th. And that is a wrap. I'm going to give you assignment 4 now. I'll keep the recording alive but dormant, so let me know. This pertains directly to problem, what is that, 3? So if you've already got past 3, like, nice job, you probably are okay, but I just want to make sure that we're all good on the multiple variable one. So I'll just do problem 3 with you, and we'll just count that as like notes or whatever. So the problem is x to the 6th minus 8y to the 9th. Yeah, and again, when I wrote this note card, I'm sure I meant to put a second variable. I ding-donged it, so my bad. So what's a x to the 2nd, right? And what is y or b? 2y to the 3rd. Good. So yeah, sorry. So we're gonna do a short set and we're gonna do a long set. And you had experience with this on yesterday's, but not necessarily with the higher power. So let's knock this out. Short set's just a copy and paste. So short set's going to be a minus b. And long set is a squared. So as Landon said earlier, x squared squared, right? Which we know as x to the 4th. It was this part that I want to make sure we're clear on. And I'm sorry to interrupt you for this, but it's important. So it's going to be plus. And when you mash those, just make sure it's, again, not wrong if you don't, but generally alphabetize your variables in the mashup. So when you mash up those two red things, you pull the 2 to the front because numbers go in front, and then you would alphabetize your x's and y's. Don't put them together because you can't, right? You know that. So I'm going to put 2x squared y to the 3rd. You see how I mashed it? And then the back is going to be, of course, plus 4 y to the 6th. Do you have any questions about that? It was this that I dropped the ball. I'll make sure to fix that before 5th hour, but this right here was what I wanted to get at, that yellow thing. Okay. Yeah.
The only problem is right.
No, anytime you see two variables, so like number 8, number 11, number 15, and number 19. If there are two different variables, then you will have to be aware of how to construct that middle term. But it's like I said, it's really no different than yesterday's. It's just we're working with higher exponents. I didn't want you to think like anything had changed. So, any questions about that? Okay, cool.